Hello all, welcome to my YouTube channel, and today we will continue the random forest classifications practical example. All these packages I'm downloading from the sklearn libraries. Different metrics will be useful for different work, but let's understand. I'm working on this load breast cancer datasets. It's a classification problem, so I'm using this inbuilt datasets which will have some features, and there will be a target variable which will basically say whether the person will have breast cancer 1 and 0, like this way. Okay, just this step is just downloading the data. I'm just printing to check what are the different keys elements are there, and then I'm just converting the data into a data frame with the header. So I found, okay, I have around 30 columns, and then along with that data I'm just adding the target variable. So finally I got this as my final data. So I have around 569 observations, 31 different features plus target, so 30 features and one target. Next I'm just splitting into X and Y. X will hold all the independent features and the dependent features will go into Y. And then I'm doing the train test split. So basically what will happen, like when I will do my training, the model training, I will use the X train and Y train. And when I will do the model evaluation on unseen data, that will be my X test and Y test. So what I'm doing, I'm simply just bringing the random forest from the sklearn ensemble random forest classifier, and by default it has a lot of hyperparameters, which if you just do shift tab you'll able to see a lot of hyperparameters are there. Quickly, some of them, if you are not familiar with the n estimators, because this was such a parameter which was not available on the decision tree, and what exactly it means, because random forest is a bagging technique. That's mean you are building number of models, and based on that then you are doing the max voting and you are getting the particular output. Here also exactly an estimator is telling you that, okay, whether you will build 100 trees or 550 trees or what is that. So just you can read this parameter part, the number of trees in the forest, the number of trees in the forest, right? So just if you need more detail, you can just go through. Criteria is Gini and entropy. Again, I think by the time you guys are expert on entropy and Gini, entropy where it's a calculation based on the log, and Gini where the calculation is more like a sum of the summation kind of logic. So that's why entropy is a little bit of complex from the time perspective, but again we are just leaving both of them, and we'll see. Max depth, again, if you just keep it none, what will happen, the max depth of the tree, if none, then the nodes are extended until all leaves are pure, until all leaves contain less than one mean sample splits. Okay, so anyway, you can just keep going and understand all these things, so not a big deal. But we will just to show that, okay, we can just create a parameter grid like this way with the different combinations, and we will try to figure out what is our best options. Okay, so we will first create the parameter grid, and then we will import the grid search CV, and then we'll create a grid search CV object, and then we'll use our X train and Y train into that object to fit it and create the best model. So finally what will happen, this grid search will be my model, and if you once you run, you'll able to see I have 5 folds because I'm using the cross validation equal to 5. My scoring parameter is accuracy, and totaling is 722 feet. So each feet will again have like 144 runs, and each run has 5 splits, so that's why 720. We will get the best parameters from this, and then we'll get the best score, which is quite a good number, 0.96. And then I normally do like this way, that I keep that result into a data frame so that I know that okay, I ran it's for 114, 44 ran, and each ran actually I have 5 split. So split 0 to 5 split, and then each split has their mean, and from there I'm taking the mean value. So this is very very good way to observe your run and all these things if you're really interested. And then using the same model on the X text, find the accuracy score, which is 97. So that's mean whatever way the model did the hyperparameter tuning, now we do not have the overfitting problem with the random forest also, because from the test data point of view I got 0.97, and from the training data point of view I got 0.96, so which is very good. That's mean it's a low bias and low variance, and which is always our goal. Okay, and then we printed the classification metrics, just what is the precision, what is the recall, and all those kind of things. So that's a very quick random forest classification practical examples. I think by the time you should be kind of expert on this kind of work. So next we will see on AdaBoost, we'll explain the mathematical intuitions, and then we will show the practical examples. And then my plan is basically show you, because the same kind of work, the same classification kind of problem you can do by different algorithms. Logistic regression, logistic classification problem is there, decision tree is there, random forest is there. So probably for any real life examples, what you have to do, you have to run the same problem using multiple algorithms, and you have to check which algorithm is giving you the best result. So that's why data science projects are basically experiment wise process. You have to do a lot of experiment, and then you have to find out what is the best model for you. There is nothing perfect, but you have to just prove it that okay, this is working better than this. Okay, that's all. Thank you. Have a blessed day. If you like it, just give me a thumbs up, support me. um, I'll try to come out with some better videos so that it will help you. And again, my intention is basically just sharing the knowledge. So if you are new on the data science space, just just try to reach me with my email or anyway. um, I will try to guide whatever knowledge I have. I'll try to share, and we can grow together. Thank you so much. Have a nice day, blessed day. Thank you. Bye.